Right now, try it. Tickle your own palm, your ribs, the bottom of your foot. Nothing happens. Not really. And that's strange because it's the same nerve endings, the same pressure, the same exact spot that would send you into helpless laughter if someone else touched it. So why does your own hand fail where a stranger succeeds? By the end of this, you'll understand why scientists believe the answer isn't really about touch at all. It's about prediction. And it might explain a lot more about you than you think. Let's start with what tickling actually is, because most people don't know there are two kinds. The first is called nismesis. That's the light, crawling feeling of a feather or an insect on your skin. It doesn't make you laugh. It makes you want to scratch. The second is gargalesis. Deep pressure on the ribs, the underarms, the feet. That's the one that triggers laughing, squirming, sometimes real panic. And gargalesis is almost impossible to produce on yourself. That's the mystery. That's what we're solving. Here's the first clue. Tickling isn't about touch, it's about surprise. Your brain is running a prediction engine every second of your life. A structure called the cerebellum sends out a kind of internal memo before you even move. I'm about to touch my own arm. It predicts exactly what that touch will feel like. When the real sensation arrives, your brain compares it to the forecast. If they match, nothing happens. Alert canceled. This is why you don't feel your clothes against your skin all day or the weight of your own tongue in your mouth. Your brain filters out anything it already expects. It's not a flaw, it's efficiency. If your brain reacted fully to every sensation your own body produced, you'd drown in noise every waking second. Tickling hijacks this exact system. When someone else touches you, your brain has no advance warning, no timing, no location, no pressure forecast. That unpredictability is the trigger. Your nervous system treats it like a potential threat, something touching you that you didn't cause and can't fully anticipate, and it reacts fast and hard. That reaction is what you experience as ticklishness. So when you try to tickle yourself, your brain already knows the plan. It cancels the alarm before it fires. Same fingers, same ribs, same nerve endings, but your brain already stamped it expected. The intensity just isn't there. Scientists tested this directly. In the 1990s, researchers at University College London built a robotic tickling machine. Participants controlled it themselves, but some setups added a small delay between pressing the button and the touch landing. The smaller the delay, the less ticklish it felt. Stretch that delay out, and the touch started to feel disconnected from their own action. It started to feel ticklish again, almost like someone else was doing it. That gap between action and sensation is the switch. Close the gap, the tickle disappears. Widen it, the tickle comes back. The more the movement was twisted away from a one-to-one match, the more ticklish the sensation became. Your brain isn't just checking timing, it's checking whether the motion itself still counts as yours. Break that match in almost any direction, and the cancellation signal weakens. Brain scans back this up. When people were tickled by another person, imaging showed strong activity in the somatosensory cortex, the region that processes touch, and in the anterior cingulate cortex, an area tied to processing alarming or unpleasant sensations. When people tried to tickle themselves, that same region barely lit up. The brain muted the signal before it ever became conscious experience. But here's where it gets stranger. Tickling isn't just prediction, it's tangled up with vulnerability and threat. Think about where people are most ticklish. Ribs, neck, underarms, soles of the feet. Almost all of these are places you can't easily see or defend on your own body. Zones near vital organs, near major arteries. Some researchers believe ticklishness evolved partly as a defensive reflex, training bodies from childhood to protect vulnerable areas and react instantly to anything unexpected touching them. That's why a sudden, unannounced tickle lands so much harder than one you see coming. It's an ancient alarm. Something's touching a vulnerable spot and I didn't approve it. Just wrapped in laughter instead of fear. And that laughter is stranger than it looks. Ticklish laughter isn't the same as laughing at a joke. Studies show it can happen even in people who describe the sensation as unpleasant, even painful, not funny at all. Babies laugh when tickled months before they understand humor. Some researchers argue this laughter is a leftover survival signal, a rapid message that says, I submit, stop, similar to behaviors seen in other primates during rough play. Chimpanzees and gorillas produce tickle laughter too, especially in young animals during play fighting, which means this response is ancient, shared across species, not something humans invented. It goes even further than primates. In the 1990s and 2000s, neuroscientist Jaak Panksepp ran experiments tickling young rats and recording their vocalizations with ultrasonic microphones. picking up frequencies far above human hearing. The rats produced rapid, chirping sounds specifically during tickling, sounds that overlapped almost perfectly with the calls they made during normal social play. The rats that chirped the most also sought out the tickling hand afterward, returning to it again and again. Rats bred to be more playful chirped more. Rats living in stressful conditions chirped less. It suggested that this laughter wasn't a cute coincidence. It was a genuine positive social response, wired into the brain long before primates, let alone humans, existed. So tickling may really be two systems firing at once: a defensive alarm reacting to unexpected touch on a vulnerable spot, and a social signal, one that helps young animals, including human children, learn body boundaries and bonding through play without escalating into real aggression. That combination explains something you've probably noticed. People close to you can tickle you far more effectively than strangers can. Being tickled by someone you don't trust can feel less like play and more like genuine distress. Same touch, same spot, completely different meaning, because your brain is reading context, not just contact. Here's a twist most people never hear about. Not everyone is equally ticklish, and some people report barely any response at all. Researchers who study this call the trait ticklishness variability, and it doesn't map neatly onto anything obvious. It isn't about pain tolerance, it isn't about being generally sensitive to touch. Some studies suggest it may correlate with personality traits like anxiety and inhibition, where people who are more anxious report stronger, not weaker, ticklish responses, possibly because the underlying alarm system is already running a little hotter. Others simply seem to have a self-monitoring system so good at predicting outcomes that even unfamiliar touch gets partly filtered. Nobody has fully solved why the range is so wide from person to person. There's one more twist, and it's the strangest piece of this entire story. A small number of people report being able to tickle themselves, or come close to it, and there's an overlap here with a rare experience in schizophrenia. Researchers found that some people with schizophrenia, particularly those experiencing delusions where their own actions feel externally controlled, are actually more able to tickle themselves than the average person. The theory: if the brain's self-monitoring system, the one that predicts your own actions, is disrupted, it may fail to correctly cancel the tickle sensation, because it no longer clearly recognizes the touch as self-generated. It's strange evidence, but powerful evidence, that ticklishness was never really about the physical touch. It's about whether your brain believes the touch came from you. So the next time you try and fail to tickle yourself, you're not missing some trick of the hand. You're running headfirst into one of your brain's core survival features, constantly predicting your own actions so it can ignore the expected and stay locked onto the unexpected. Tickling only works when your brain gets caught off guard, and your own hand, no matter how sneaky you try to be, never manages to surprise you. Which leaves one question hanging. If your brain edits touch this precisely, canceling what it already expects before it even reaches your awareness, how much else of what you feel is being quietly rewritten before you ever notice? Pain, itch, even pleasure. You may not be experiencing your body directly at all. You may be experiencing your brain's best guess about it.